Okay, let's go step by step. And the first thing to recognize is that the first one that we need to do, the first integration, is really simple to do. I could have done that in the beginning, by the way. I mean, the very first time we did a partial fraction, we could have done that. The next one, a little more difficult, but let me write it down for you. What I would write down over here is make a u substitution. I'd say u equals, and what is u equal to? It would be 2x, I'm doing the second integration now, minus root 3. What would du equal to? 2 dx. So again, it looks fairly simple to do. It's 1/3. I'm gonna put a little star here. I get 1. This would be u squared plus 1. And dx is 1/2 of a du, which is gonna give me 1/6 of an arctangent of a u. What's u? It's the 2x minus root 3 plus some constant integration. Let me tell you where that's written. I see that written right over here. All right. Now, by the way, this one is almost identical to this one over here, so it's pretty simple. All right. So we have 3 integrations done. Let's go to our next integration. All right. I'm going to erase this over here, and I want to see if I can do those next 2. And to do the next 2, I would definitely do a u substitution again. All right. So what u substitution going to do? Well, this is deja vu. Let's write this down for you. U equals, and I'm going to, let me put what I'm doing over here. We're doing this one over here. So u equals, let's write this down, 2x plus root 3 squared plus 1 du. Let's write this down, 2 times 2x plus root 3 squared. No, I'm doing derivative. I'm sorry, 1 times 2 dx. And so let's take a look at this. Du, let's see, that's going to be 8x plus 4 root 3 dx. I am going to multiply both sides by the root of 3. Let's write this down. So you get root 3 du is equal to 8 root 3 plus 12 dx. I am going to divide both sides by 4, and you get root 3 over 4 du, and that's going to be 2 root 3. You know what? I forgot the x there. Sorry about that. I just noticed it. And that's going to be plus 3 dx. All right. I'm seeing it. And someone says, where are you seeing it? Right over here. All right. So what does my integration look like now? And I'll write it down for you. It's still going to be 1/3. I'm seeing I got a 1 du here. Maybe I shouldn't see a du so quickly. 2 root 3x plus 3 is not really du. It's 3/4. I'm sorry, root 3 over 4 du. Let me write that over here. Root 3 over 4 du. And what goes on bottom is just u. So let's write this down. You're going to get root 3 over 12 times the natural log of the absolute value of u. And what's u? U is this business over here. All right, let me write that down for you. So it's 2x plus root 3 squared plus 1. All right? So I'm going to claim, it wasn't bad to do. I mean, we did get this over here. And by getting this, I'm pretty comfortable that if you can do that one, you could do the other one too. Like, for example, this one here, it's almost the same thing. I'm just going to write it down over here. I realize some students looking at this and saying, how did you do the next step? Right? How did you do that? Well, I want to go through it with you. I'm going to erase this over here. And I want to go to this next step. And what's the next step going to be? How did they go from here to here? Let's write this down. And I want to emphasize to you that I'm really doing 2x plus root 3 squared plus 1, the absolute value of it. The first thing I notice about this over here, it's always positive. So I'll write this down, 2x plus root 3 squared plus 1. I multiply it out. What do you get? 4x squared. That's not too difficult. You're going to get, let's take a look at that. You get 2 root 3, 4 root 3s. And then you get 3, and 3 plus 1 is 4. And then I factor a 4 out, and what do you get? X squared. This is x, sorry about that. Root 3x plus 1, all right? And what do we do with that? Take the natural log of that, all right? The natural log of that, I'll write that down for you, is going to be 4 times x squared plus root 3x plus 1, and that's going to be the natural log of 4 plus the natural log of x squared plus root 3x plus 1. All right? Now, someone says, is it really necessary to do that? It does make it a little bit cleaner for me. And what I do is I take this constant and I just integrate that constant into another constant. I'll call it C5. So what are you left off with? Well, you're still left off with the root 3 over 12, but now I get a much simpler log over here, and that's written right over here. Likewise, if you can do that one, you can do this one over here. It's almost identical in process, by the way. All right? We need to pull these all together. That's our next step, by the way.